8.1, the fundamental counting principle. So the fundamental counting principle is a way to help model how many different options things can have. So we can do that with a diagram. So we have what is called a tree diagram. So a fan has 3 settings of off, low, and high. How many ways are there to set 3 fans? So our first option is we can choose between the fans. So we have fan number 1, we have fan number 2, and then we have fan number 3. And each of those fans can be set to off, low, or high. Off, low, or high. So we can count all of the ends of the branches. So 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 options for setting these fans. We can also do this with the fundamental counting principle. So we can have 2 lines. Each one is going to represent an event. The first one is which fan you are using, and the second event is the setting. So there are 3 fan options and 3 settings. Multiply them together and you get 9. So obviously tree diagrams is not going to be super realistic in real life because having to draw those out will suck, especially when we're starting to deal with big numbers. So we use the fundamental counting principle because it gets us the same answer. So an online banking account, there's a minimum security standard to have 2 letters followed by 5 digits. The passwords are not case sensitive and no characters can be repeated. How many passwords are possible? So we have 7 spaces. These ones have to be letters and these ones have to be numbers. It is not case sensitive, so that means that there's only 26 letters to choose from. It also tells us that we can't repeat. So once we've used one letter, we only have 25 to choose from. We're using the digits from 0 to 9, which means there are 10 numbers. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That is 10 items. So 10 numbers could go here, leaving 9 for here, 8, 7, 6, and then our final answer, we will multiply them all together. And there are a possible 19,656,000 different passwords possible. So there is a lot, as you would imagine. Okay, you're making a password and you want to use 3 odd numbers, 3 vowels. How many passwords are possible? So we have 3 odds and then 3 vowels. So our odd numbers are 1, 3, 5, 7, 9. And our vowels are A, E, I, O, U. So there's 5 vowels and 5 odd numbers. It doesn't say that they can't repeat. So there's 5 here, 5 here, 5 here for the odds, and then same with the vowels. So it's actually going to be the same as 5 to the power of 6, which is 15,625 possible passwords. And that's the fundamental counting principle.